What a control valve does. A control valve is the final control element in a process loop. It receives a signal from a controller via a positioner and changes its opening to throttle flow of process fluid, gas, liquid, slurry, or in our plant's case, often hot gas, fuel, or compressed air streams. Everything upstream transmitter, controller only measures and decides. The control valve is what actually acts on the process. Core idea: a plug moves relative to a fixed seat, changing the flow area orifice between them. Bigger area right pointing arrow more flow. The plug position is set by an actuator, which is driven by a pneumatic signal, typically 3 to 15 psi from a positioner receiving a 4 to 20 mA controller output. One diaphragm actuator converts pneumatic signal pressure into stem force against a spring. 2 yoke bonnet structural connection between actuator and body, guides stem. 3 stem transfers linear actuator motion to the plug. 4 plug variable restriction element, its shape sets the flow characteristic. 5 seat fixed sealing ring, defines maximum orifice and shutoff point. 6. Body pressure boundary with inlet-outlet flow passages. 7. Packing stem seal preventing external leakage. How the loop closes. Controller output 420 mA sets the demanded position. Positioner's flapper nozzle compares demand to actual stem position via the feedback cam and lever. Any error changes nozzle back pressure, which the positioner's relay amplifies into a change in air output pressure. Air pressure moves the diaphragm against the spring, driving the stem and plug. As the stem moves, the feedback lever rotates back, reducing the error to 0, the loop settles. Why a positioner matters. Without a positioner, actuator position is affected by friction, packing drag, fluid forces on the plug, and supply pressure variation, so actual position drifts from demand. Toggle stiction above. The stem won't move until the error builds up enough to overcome friction, then it jumps and overshoots slightly before settling. This is exactly the pattern we see on loops with worn packing or a tired positioner diaphragm, and it's a common root cause of loop instability during troubleshooting. Fail-safe action. FO versus FC. On loss of air supply or signal, the actuator spring drives the valve to a predetermined safe position. This is selected at design stage based on what's safest for the process if control is lost. Fail open FO. Spring drives valve fully open on air loss. Used where blocking flow on air failure would be dangerous, e.g. a cooling water valve, or a vent relief path. Typically an air to close actuator. Flow characteristics. The plug's shape determines how flow rate relates to stem travel, valve opening % at constant pressure drop. Select a characteristic to see its curve in typical use. Linear characteristic. Flow rate changes in direct proportion to stem travel. 50% opening gives roughly 50% flow. Simple, predictable gain across the whole range. Good general purpose choice for flow control loops where process gain is fairly constant. Equal percentage characteristic. Each equal increment of travel produces an equal percentage change in the flow that already exists. Small change at low opening, large change at high opening. Compensates for systems where available pressure drop across the valve drops sharply as flow increases, e.g. pressure control in many pump system curve situations. Quick opening characteristic. Most of the available flow is achieved in the first portion of travel, then the curve flattens. Suited to on-off type service, relief applications, or where a fast initial response is wanted rather than fine modulation. Control valve in the control loop. The control valve is one link in a closed loop. Understanding its place helps in troubleshooting. A control problem is often not the valve itself but the transmitter, controller tuning, or air supply feeding it. Closed loop check when a valve seems faulty. Confirm air supply pressure at the actuator. Confirm positioner responds to a manual signal change. Confirm stem actually travels full range, then trace back to controller output and transmitter reading before condemning the valve trim.